Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing, jaw-dropping scientific discoveries that are revolutionizing our world and touching our lives. And in this hour, once again, this is your hour. That's right. You can get to the phones, give us a call, and you can be part of the fun. Why should we scientists have all the fun probing the mysteries of the universe? Okay, well, without further ado, let's jump right into the calls that are coming in. Let's take the first listener phone call.
Hello, my name is Nori. I am from Hollywood, Florida, and my question for science is about the existence of God. Can science support or answer theories about God?
Okay, well, you ask a mouthful, but let me try to attack that question by, first of all, mentioning the fact that sometimes people set up websites in my name and actually put words in my mouth. I didn't think this was possible until it actually happens. In fact, there's a website that even claims that I claim to have proved the existence of God. Well, let me say right now that that is a bogus website. I did not create that website. I do not have a proof of the existence of God. However, I have definite attitudes towards such an endeavor. I was once in a debate in Mexico City. In fact, it's on YouTube if you dial into it. And on one side was priests from the Catholic Church who believed in the existence of God, and on the other side were atheists who said, bah, humbug. And one side said you could prove the existence of God, and the other side said you couldn't. And then the moderator asked me in the middle, what was my point of view? And my point of view is that it's not a scientific question. Science is based on things you can test, things you can reproduce, things that are falsifiable. You cannot prove or disprove the existence of God. Nobody has been able to come up with an experiment by which you could conclusively either way prove or disprove the existence of God. And so I told the moderator that 100 years from now, they will be sponsoring similar debates with the same question that is unanswered. Even with advanced technology, we will not be able to make a definitive statement. However, I have definite attitudes toward religion, science, and God. For example, I think Galileo said it best. Galileo said that the purpose of science is to determine how the heavens go. But the purpose of religion is to determine how to go to heaven. So, in other words, religion concerns ethics, how to be a good person, how to go to heaven. However, science deals with natural law, that is, how the heavens go. So as long as we keep these two things separate, I think we're in great shape. They're complementary. That is, people who are religious can tell us what is the good, what is the best behavior that we should perform, and scientists can then talk about galaxies and stars and planets and asteroids. The problem is when, let's say, the Catholic Church begins to pontificate about the shape of the earth, or when scientists begin to pontificate about people's behavior, that's when we get into trouble. And again, Einstein was asked this question repeatedly, and he basically said that the problem is ill-posed. That is, there really are two kinds of God, and we have to keep these gods separate. One is the personal God, the God that you pray to, the God that smites the Philistines, the God that walks on water. That's the personal God that he had trouble believing in. However, Einstein did believe in God, but the God of Spinoza, that is, the God of beauty, harmony, elegance, that the universe could have been random. The universe could have been ugly. It could have been, for example, nothing but a bunch of electrons creating a mist of subatomic particles. Very uninteresting, very boring, and that's not our universe. We have consciousness, we have beauty, we have elegance in this universe, and it didn't have to be that way. And so then Einstein said that he feels himself like a child a young boy entering this enormous library with thousands and thousands of books. And all he could do is take the first book and read the first page of the first book. So he thought it was humbling knowing that there is an ocean of undiscovered knowledge and information out there, and all he could do was read the first book and read the first page. So he believed in God, but not the God that gives you a present at Christmas, not the God that smites the Philistines. He did not believe in a personal God, but the God that created the universe itself. Okay, well, let's go right on to the next question. Hello, you're on the air.
Hello, this is Armand from Bayside, Queens. How are you doing, Michio? I was wondering if one day there'll be a way to bypass the coding system and create video games and movies and landscapes with your mind. Because I have a lot of great ideas, but I don't know how to code. Thank you very much, and have a great day, Michio. I appreciate it.
Yes, you're absolutely right. That is, of course, a few decades away, but one day we'll be able to directly, via the mind, create images and games and pictures. You can see the beginnings of this already. First of all, when computers were first invented and first harnessed, scientists did what is called machine language. That is, lines of code in binary format. So if you were to look at the codes, it would look like a bunch of hieroglyphics, a bunch of zeros and ones, zeros and ones. And so the first language that we communicate with computers was machine language. Then after that, we began to create languages like Fortran and languages written in English, but again, laying out the basic structure of the program. And then we invented compilers that would compile these programs like Fortran and Balgol and Algol and convert them to zeros and ones, zeros and ones. Now we have higher languages like HTML by which you can design web pages, but you still have to know the codes. Wouldn't it be better just to think it through, think of a web page and have it, boom, displayed right there on your computer screen? And that's coming. However, it's going to take some time. First of all, at Berkeley, University of California, Berkeley, where I got my PhD so many years ago, scientists there have hooked the brain to a computer by which we're able to actually photograph your thoughts. Here's how it works. You put your brain in an MRI machine. The MRI machine then calculates blood flow in 30,000 locations inside your brain. So a computer now has in its memory blood flow in 30,000 dots or pixels that make up the human brain. Then it runs a software program that analyzes that, and bingo, it prints out a picture of what you're thinking. If you get a copy of my latest book, The Future of the Mind, you can actually see what these pictures look like. They're not perfect. A picture of an elephant or a picture of an actor look kind of blurry. But the very fact that we can even talk about this and not laugh is amazing. Absolutely amazing. In fact, you can even photograph a dream, because when you go to sleep, your brain just keeps on chugging away and divides your brain into 30,000 pixels, calculates blood flow, analyzes the blood flow, and then constructs a picture. So one day you'll wake up and you'll push a button and see the dream that you had the previous night. Think about that. Well, once again, this is Dr. Michio Kaku, and this is Okay, well, moving right along, let's take the next listener phone call.
Hello, this is Joan from New York, and I was wondering about what you were saying on YouTube. You're talking about how pretty much sleep paralysis is when you feel something on your chest. But with me, I felt it on my side, and it was like a ghost. And do you think that ghosts can exist in a different dimension or a parallel universe? And also, you said that the person could remember the feeling through hypnosis or psychiatric evaluation, but I can remember it quite vividly without having to have any of that done. And I was able to draw myself out of that state through force of will. But the longer I stayed in that state, I felt more and more intense fear. All right. Thank you very much.
Well, you actually ask a rather profound set of questions about the workings of the human brain. You know, many scientists hear about alien abductions, and they laugh and they giggle. But think about it for a moment. School teachers, policemen, people that have everything to lose, people that have very good reputations in society, yes, they believe they've been abducted by flying saucers. How is that possible? Not just one or two, but thousands of these people, reputable people. Well, we think we know the answer, though we're not sure, of course. Maybe they were abducted. However, sleep paralysis may explain some of the more bizarre aspects of the human mind. So you see, when you dream, you are paralyzed. That's right, you are paralyzed when you dream. Otherwise, you would act out the dream, creating enormous problems. In fact, there was one gentleman that actually killed his wife during one episode, and he actually was let go because he had a long history of sleep paralysis. Well, it turns out that about roughly 5% of the human race, when they wake up in the morning, they are still paralyzed. When you wake up in the morning, most people just wake up, their bodies can move, their muscles can move, and off they go to start the day. But these individuals, about 5% that have been analyzed, are still paralyzed, and they can't move, and they have this fear, and they're also slightly sexually excited during this process, and they have this image of a cat or a gremlin or an animal sitting on their chest staring down on them. In fact, during the Victorian era, there are paintings. You can Google this. There are paintings of sleep paralysis where women are asleep and there's a gremlin standing on their chest staring down on their sleeping body. Then you wake up, your muscles are energized, and you forget the episode. Under hypnosis, you can bring back that feeling of fear of someone staring down on you as you're paralyzed. In fact, one friend of mine says that she thinks there's a cat. She visualizes a cat standing on her shoulder when she wakes up. And when I teach astronomy to hundreds of students, I take a poll right there, right on the spot. I ask several hundred students how many people have sleep paralysis. That is, they are paralyzed when they wake up. I'm shocked. About 5% of the class raises their hand right in front of me. Now, some scientists claim that this feeling evoked under hypnosis is kind of blurred as a consequence, and they think that maybe they're in a flying saucer. They think that aliens have paralyzed you, and they're doing forbidden experiments on your sex organs, and many scientists believe that is the origin of sleep paralysis, maybe even the origin of the ghost phenomena. Now, the caller asked a number of questions, and I'll have to take them separately. First, sleep paralysis is real. And it's been with us for thousands of years, ever since we learned how to dream way back in prehistory. Under hypnosis, you can retrieve these memories, or if you're good enough, you could probably remember that feeling of waking up in the morning. My friend who thinks there's a cat sitting on her chest, yeah, she remembers these things quite vividly without hypnosis. Now, ghosts is a whole nother thing. First of all, scientists do not believe in ghosts. However, there's one form of ghosts that might actually exist. And this goes back to what is called the Schrödinger cat problem. In quantum mechanics, that is atomic physics, you can have electrons that are neither here nor there. They can be two places at the same time. If an electron can do it, then maybe a cat can do it as well, in which case you can have a dead cat and a live cat simultaneously. This is called the Schrödinger cat problem. It's perhaps one of the deepest paradoxes of all time. And yes, it means that dead people may actually be alive in another universe. So I'll talk about that. In fact, I'll quote from a Nobel Prize winner who says that, yes, in principle, someone who's dead in one universe could be alive in another universe. Think about this. This is modern physics, not hocus pocus. So let's take a short commercial break.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Why not be part of the fun? Why don't you just get to the telephones and give us a call at 866-323-2129. Okay, well, let's move right along. And, well, before I take the next listener phone call, let me finish the previous call that came in before the commercial break. And that concerns ghosts. Well, first of all, let me say very clearly, without hesitation, there's no such thing as ghosts. Okay, scientists have tried to measure them, tried to find them, locate them, test them. So far, we come up with zero. However, in the world of quantum mechanics, even though ghosts may not exist in this world, can they exist in another world? And there the question is rather hazy. Because, you see, according to quantum mechanics, cats can exist both dead and alive. Electrons can be both here and there. This is called quantum spookiness, and we measure it in the laboratory every day. In fact, whenever you turn on your cell phone, you're using this quantum spookiness, that electrons in your cell phone can be here or there simultaneously. In other words, everything is vibrating, and things can vibrate at different frequencies. Now, Steve Weinberg, winner of the Nobel Prize, puts it this way. Think of a radio in your living room. The radio picks up all sorts of radio waves from around the world, Radio Moscow, for example, commercial radio, all sorts of stuff, but it's tuned to one frequency. So your radio, even though it in principle could pick up all sorts of frequencies, is tuned to one frequency. Now, in quantum mechanics, everything is vibrating. Everything is vibrating. Electrons vibrate. Everything is vibrating, but vibrating at a certain frequency. However, there are other frequencies that you cannot see or touch. And these frequencies, these other frequencies, could be the frequencies of pirates, aliens, dinosaurs, or people that have died in your universe. Yes, it's possible that if you could somehow change your frequency, you might be able to go between universes. However, Steve Weinberg, Nobel laureate, is very careful to say that if you calculate using quantum mechanics, the probability that you could enter another universe where someone who's dead in your universe is alive in another universe, you would have to probably wait longer than the lifetime of the universe. In other words, it ain't going to happen anytime soon. So even though we physicists can contemplate the idea that you could be dead and alive simultaneously, even though we give homework assignments asking students to calculate the probability that one day you'll meet Elvis Presley, the probabilities are so small, it's not going to happen in the lifetime of your universe. So, in other words, unfortunately, Elvis Presley has passed away, as far as your universe is concerned. But there are, other universes out there. We're not tuned to them. And to go between channels is beyond our technology. So, sorry about that. Okay, well, let's move right along and take the next listener phone call.
Hi, Professor Kaku. This is Andrew Smith from Utah. I'm a big fan of your show. I have a question for you. So there are some theories that subatomic particles can move backwards in time. If that's true, couldn't those particles interact with particles from the past? And if so, isn't it possible for a chain reaction to occur backwards in time? That's it. Thank you.
Well, at first your question sounds like a bunch of nonsense. However, it's actually correct. The person who figured this out is Richard Feynman, perhaps the greatest physicist of the early part of this century. He won the Nobel Prize in Physics, in fact, for what is called quantum electrodynamics, that is the interaction of light with electrons and matter. And he asked himself a simple question. The laws of physics says that particles move forward in time. Everybody knows this. I mean, after all, eggs do not suddenly jump into their shell after they're hatched. You do not simply jump back into the grave. Everything goes forward in time. But after the break, I'll ask another question. What happens if you spin the dial backwards, and all of a sudden dead people come out of the grave? All of a sudden, broken eggs, jump right back into the shell. What happens then? I'll answer that question after the break.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Keep the calls coming. The number to call is 866-323-2129. Okay, well, before the break, we had a question that came in about particles going backwards in time. This question was asked by Richard Feynman, Nobel Prize winner, and the answer is yes, you can have particles that go backwards in time. When an electron goes backwards in time and you kick it to the left, it goes to the right. In other words, it acts as if it has the opposite charge. If you kick an electron, let's say it goes to the left, it has negative charge. But if it's going backwards in time, you kick it, it goes to the right. In other words, it acts as if it has positive charge. So in other words, antimatter is matter going backwards in time. And so he brilliantly explained why we have matter and antimatter. Antimatter looks like matter, except it has the opposite charge. Antimatter is matter going backwards in time. And then the question that was asked is, what happens if a particle of matter collides with another particle of matter going the other way in time? What do you get? You get an explosion. In fact, that's why matter-antimatter explodes. If you are a Star Trek fan, you know that the impulse engines of the Enterprise is based on antimatter engines. That is the collision of antimatter and matter that release energy. But where did this energy come from? Why do you have matter and antimatter annihilating each other? Because one particle is going forwards in time, the other particle is going backwards in time, and when they meet, watch out, you get an explosion. And one day, that could take us to the stars, because this would give us a fuel that is 100% efficient, that might take us to the stars. So this simple question asked by Richard Feynman back in the 1940s, can you go backwards in time? The answer is yes at the subatomic level, in which case, one day, we might be able to build a starship.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. Okay, moving right along. Let's take the next listener phone call.
This is Don L. I have a theory that it's a theory my brother has. He postulates that if the Earth or if the universe ceases to expand and comes back and there's another Big Bang, is it possible that we have been here before and that we will live again someday, assuming that everything would go out at the same as it did originally? Thank you, sir.
Well, you ask an age-old question, first asked by Friedrich Nietzsche, the German philosopher, and that is, if the universe can repeat itself once, does that mean it has to repeat itself continually till the end of time? So in other words, if we have a Big Bang, and then we have a big crunch, and then we have another Big Bang again, will we repeat the same mistakes, the same goofy mistakes we did in the previous cycle trillions of years before? Well, the answer is probably no. We don't know for sure. But we have something called quantum mechanics, which says there's a probability that all sorts of stuff could happen. So each time the universe would repeat itself, it would be slightly different. Now, our present-day understanding is that there was a Big Bang, and it's accelerating. It's not contracting at all. It's simply going to expand faster and faster for reasons we don't really understand. But if you measure the expansion, it's accelerating. However, That doesn't mean that at some point in the distant future it may stop and then begin to contract again. We don't know. In fact, Stephen Hawking once believed that if the universe were to stop and contract, the universe would start to go backwards. That is, time would start to run backwards as the universe contracted. He has since given up that idea. And again, it's because of quantum mechanics. So even if you start the universe moving in one direction, there's always a probability that it'll swerve and go into a different universe. So in other words, you cannot predict with accuracy because of uncertainty. There's always uncertainty in the motion of subatomic particles. Therefore, the universe is not going to repeat itself. Therefore, you're not going to make the same dumb mistake over and over again. Okay, well, let's take the next listener phone call.
To accelerate a human body up to light speed, could we tune into the gravitational pull of other celestial bodies so that everything would be accelerated at the same time and the occupant would not become a thin smear of grease on the back wall of the spacecraft?
So in principle, you're squashed because you're being pushed into your seat because your rocket ship is accelerating. And on the other side, you have stars that are pulling you in the other direction. In principle, yes, they could cancel, but it's extremely unlikely. Think of what you would have to do to get this experiment done. But in principle, the answer is yes. In practice, the answer is no. Okay, well, let's take the next listener phone call.
Yes, I'm calling from Central Missouri. My name is Vic. I've heard your explanation about the expanding universe being the balloon. We're on the surface of the balloon, and the ant crawls around it, so we can't see the center where the Big Bang was. But that begs the question to me is, what's inside the balloon? As the balloon expands, there's got to be something inside the balloon, not just the surface of the balloon alone. And also, what's outside the balloon?
Okay, to be very clear, what's inside and outside the balloon is another dimension. Now, the ants on the surface of the balloon can't see this other dimension. So for all intents and purposes, it looks as if the universe is mysteriously expanding. But yes, if you had hyperspatial eyes, you could see that there's an inside and an outside to the universe.
Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science and technology that are going to touch our lives and affect human destiny. And if you've been following the news, you know that Elon Musk, the visionary behind SpaceX, many people compare him to Tony Stark, the man behind the Iron Man comic book series. Many people think that Elon Musk is prophetic in terms of talking about cities on Mars. That's right. Forget about putting an astronaut on Mars. We're talking about putting a city on Mars with 1 million inhabitants. An incredible press conference that is already generating a tremendous amount of excitement and some skepticism. First of all, in 2 years, he wants to send the first unmanned rocket from SpaceX to the planet Mars. 2018, the first unmanned mission to the red planet. And then 2024, hold on to your hats. 2024, he wants to send the first manned mission to the red planet, beating NASA by perhaps 10 years. NASA hopes that perhaps by the early 2030s, it may have a mission to Mars, maybe orbiting around Mars, and actually landing on Mars perhaps in the 2040s. Well, Elon Musk says that private enterprise and ingenuity and individualism, he can actually beat NASA's time frame. This is potentially amazing. And then he envisions perhaps sending 1 million colonists and tourists to the red planet. He envisions having 1,000 Mars ships in orbit, each one containing 100 colonists, to begin the process of creating a multi-planet species. In other words, it's too dangerous, he says, to put humanity in one basket because, for example, asteroid strikes, global warming, rampant biogerms, whatever, can wipe out humanity. It's simply too dangerous. We need an insurance policy. We have to put astronauts on at least 2 planets, maybe more. And he wants to be the man to do it. In fact, that's one of the reasons why he created SpaceX, which has already revolutionized space travel by introducing the reusable rocket. He wants to reduce the cost of space travel by perhaps a factor of 10. So instead of costing $10,000 a pound to put anything in near Earth orbit, it may cost $1,000 a pound to put anything in near Earth orbit, which could literally open up the heavens for commercial space travel. So is it outlandish? What's the catch? Well, there is one small catch. Actually, 2. First of all, it is dangerous. He publicly admits that, yes, people will die. Let's get used to that fact that there is something called the Mars jinx. Something on the order of 30-40% of our space probes really never make it to the red planet. But more important is cost. That 4-letter word, cost, C-O-S-T, it'll cost about $10 billion to send the first of these missions to the red planet. Eventually, the cost per passenger will be down to about $200,000. Imagine, $200,000 per person to go and visit the red planet. And of course, he's a realist. He says it'll take a public-private consortium. In other words, even he, the billionaire, does not have enough money to single-handedly fund this manned mission to the red planet all by himself. It'll be a combination of public and private funding. But already he's revolutionized our understanding of space travel by reducing the cost, by making reusable rockets part of the inventory of the space age. So hold on to your hats. Perhaps by 2024, we will see humans on the red planet. Amazing. Well, once again, we're going to introduce our 2 special guests today. The book is called Beyond Earth, Our Path to a New Home in the Planets by Charles Walford and Amanda Hendricks. Find out about what it means to blast off to Mars and even Titan, a moon of Saturn, in this edition of Science Fantastics.
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about exploring the solar system in a way that you've never heard before. Perhaps you heard the statements from Elon Musk talking about the colonization of Mars. So we're not talking about the moon. We're not talking about the space station. We're talking about going to the planets. What's out there beyond the moon? What about Mars? Is it possible that one day we'll have a colony on Mars? Or for that matter, what about the other planets, all the way going out to Saturn and maybe even Titan? With us today, we have 2 distinguished guests, author of a new book, Beyond Earth, Our Path to a New Home in the Planets. We have with us Charles Walford. He's the author of 10 books, hosts a weekly interview program for Alaska Public Radio. And we also have Dr. Amanda Hendricks, a planetary scientist who's worked 12 years for NASA's Propulsion Laboratory. So Charles and Amanda, glad you could be on Science Fantastic.
Thank you.
Thanks for having us.
Okay, Charles, well, the first question for you, the question that we always ask our guests is, how did you as a youth first get interested in science and in your field also journalism?
Well, I guess beginning in science for me was all about kind of the natural environment. I grew up in Alaska, so it was the tide pools and outdoors, and this is something that made this project interesting for Amanda and I, because she's very much a space scientist, and I came more from an environmental background, so it gave us 2 different perspectives on this topic of moving, to another planet. In terms of science writing, I was deeply involved in reporting on the Exxon Valdez oil spill in Alaska, which turned out to be a really big science topic. And so that made me realize that science was really, the scientific viewpoint on the world was really a great avenue to truth and to writing fascinating, important topics.
Okay. And Amanda, how did you get started being interested in science?
Well, for me, it started in school. when I was in second or third grade and we learned about the solar system at school, I fell in love with the topic, and I decided I loved the planets. And at around the same time, the first Viking lander landed on Mars, and so we had the first images of another planet taken from that planet, and showed us the landscape of Mars, and that was it for me. I was done.
Okay.
And so from that point, I decided I wanted to do something involving the planets and space for the rest of my life.
Okay. Now, Charles, you probably heard the big news. Elon Musk, who's been compared to Howard Hughes and to Tony Stark of science fiction fame, has announced a rather ambitious program to explore not just the moon, but to go way past the moon onto Mars. So let's break it down for a moment, okay? Where are we in the space program today? And do you think that it is reasonable that we can begin the possibility of sending, well, in his case, space tourists to Mars? What are your thoughts?
Well, I definitely think we need to be working on it, but there are some really huge challenges to getting people there that are in the way, and that NASA and all the space community needs to do concentrating on much harder, having to do with the galactic cosmic rays and the impact of that radiation on human health. One thing that we looked at was that there really there's too big of a health risk at this point to going to Mars without some substantial science breakthroughs to get there faster, so that radiation exposure is not as long, both in terms of cancer risk and in terms of cognitive impacts on the brain of these large ions coming from the cosmic galactic rays. So that's something that we studied hard in the book. We wanted to write in Beyond Earth very realistically. We didn't want to just imagine what could happen. We wanted to document what was really possible. And at this point, I think Elon Musk is probably overreaching, because I don't think that he could get 1 million people there, but I don't think he could get them there healthy or stay healthy until there's some breakthroughs.
Okay. Amanda, there are some deniers who deny that we even been to the moon. And these so-called skeptics say that, well, surrounding the Earth there's a Van Allen belt, which is quite radioactive and dangerous, and there's no way that our astronauts could have gone through the Van Allen belt to the moon. Well, forget the Van Allen belt. We're talking about Mars now. So tell us, how dangerous is it in outer space about the Van Allen belt? And I understand that cosmic rays are so plentiful out there that even in the eyeball, that you can actually see flickers of light in your eyeball because of cosmic rays that go through the fluid in your eye. Could you elaborate?
Right. So that has been seen since the first days of sending humans into space, that there have been vision issues that only recently on the space station have begun to be more thoroughly studied. And, you know, the true aspect of the problem has been realized. And that has to do with radiation from the sun, but as Charles was pointing out, the even more dangerous radiation is the stuff that is really difficult to shield from, and that's the galactic cosmic rays. If I can go back to the Elon Musk thing, though, I would say that it's really terrific in a lot of ways that he is doing this whole program, because if we want to send humans to other planets, NASA can't do it alone, and even all of the space administrations from all the different countries can't really do it alone. So it's really important that nowadays the commercial industry is getting so involved. So I think it's really great. However, again, there are significant health risks that need to be addressed if we want people to get to Mars or other planets and then survive there for a long period of time. Elon himself, I think, acknowledged that there's going to be a lot of deaths along the way. And that's certain to be true, but you do have to start somewhere. And so I'm feeling somewhat positive about his whole plan in a lot of ways.
Okay. Now, Charles, it's always great to see our astronauts spinning upside down and waving at us under weightlessness. But weightlessness has a downside, too, right? I mean, the Russian astronauts, Commander Polyakov, after spending over a year in outer space, when he came down, he had to crawl like a worm. There was so much muscle atrophy that he couldn't even walk. Could you elaborate about the problems of weightlessness?
Yeah, one of the several astronauts we interviewed, Mike Barrett, described coming back to Earth as being a refrigerator magnet. You just felt like the Earth was cranking you down with its gravity. And that has many physiological effects. NASA has done a good job of doing countermeasures on some of them that were most obvious, including the loss of muscle mass and the loss of bone density, which are pretty serious and happen pretty quickly in space, just because you don't have the resistance of gravity to help those cells build while you're, as they do on Earth. But what has been discovered more recently is this thing that Amanda mentioned, which is pressure in the eye, intracranial pressure, which is caused by your cerebral fluid building up in the head and not circulating normally, appears to damage or cause impact on the optic nerve, which after a certain amount of time could be irreversible and cause blindness. And that's something that's been a big concern for the last few years for NASA and really has not been solved. The only clear solution to it would be either get there quickly so that the damage doesn't become too severe, or use artificial gravity with some sort of centrifugal motion on the spacecraft so that you have the effect of gravity causing your cerebral fluid to continue circulating. So that's one of these major health issues that has to be resolved, and it's probably not impossible to resolve, but it will require more investment and more concentrated effort, which I think Amanda and I really feel would be help created by a goal like space colonization, which is what we address in Beyond Earth, our book.
And Amanda, as was mentioned by Charles, you can spin the spacecraft, giving you artificial gravity. But if you use Newton's laws of motion and do a back-of-the-envelope calculation, you would have to have a rather expensive spacecraft. It would have to be rather large, and spinning it would be impractical. Or what are your thoughts? You think that at some point in the future we may be able to solve the problem of weightlessness?
Yes, I think that, and we spoke with a couple of experts on this topic, structures and artificial gravity for Beyond Earth in our research, and I think it's certainly doable and absolutely necessary, as Charles points out, for health concerns. But it will be complicated. It is a non-trivial problem, but you can, just like in the old days of science fiction, you can create, for instance, a wheel-shaped spacecraft that's spinning at a certain rate. It depends on how big it is and how much gravity you want to create. That all depends on how fast you want to spin it, and that depends on structural integrity and so forth. So there's a lot of different components that go in. You can make a spacecraft where part of it is spinning, and so there's a lot of different ways to do it, and it's complicated and it does get expensive, but it is necessary. And people are really thinking about this. This is going to be the way that it's done. I'm convinced of it.
We have to take a short commercial break, but after the break, we're going to continue a discussion of the colonization of Mars. Forget the moon. We're talking about Mars. We're talking about Titan. We're talking about exploring the solar system with Charles Walford and Amanda Hendricks, and the book is called Beyond Earth, Our Path to a New Home in the Planets.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Charles Walford and Amanda Hendricks. And the book we're talking about is Beyond Earth, our path to a new home in the planets. And as you probably heard, Elon Musk, the driving force, the billionaire behind SpaceX, has laid out a roadmap by which we can begin to put cities, not just astronauts. Forget that. We're way beyond that. We're talking about cities on Mars. We're talking about perhaps 1,000 starships, 1,000 interplanetary ships with perhaps 100 tourists on each one, potential colonists beginning the process of colonizing Mars. Well, let's bring it back down to Earth. Once again, we have Charles Walford. He hosts a weekly interview program for Alaska Public Radio. And we have Dr. Amanda Hendricks, planetary scientist, and has worked 12 years at NASA's Propulsion Laboratory. So, Charles, let's break it down now. Elon Musk laid out a time frame, 2 years. He expects a modified Falcon rocket, an unmanned rocket, to reach Mars. And then by 2024, perhaps 10 years before NASA, he wants the first ship to go, a manned ship to go to Mars, and eventually envisioning 1,000 such ships, each ship containing 100, colonists to go to Mars. Let's break it down. First of all, do you think it is reasonable, the time frame that he mentioned, 2024, to send the first manned mission to Mars, beating NASA by perhaps 10 years?
Well, I mean, it's hard. You don't want to bet against Elon Musk. He's accomplished some extraordinary things with SpaceX and with Tesla and with Solar City. But also, if you look at his record, he tends to predict things are going to happen a little bit quicker than they actually do, because the technical challenges of building rockets and of making these extraordinary leaps are very, very high. The thing that we found in working on Beyond Earth was that Musk has really figured out how to innovate in a way that NASA doesn't know how to do or has forgotten how to do. We went to his plant and met with one of his engineers, and they really have a kind of Silicon Valley agile innovation culture there, where they're able to make advances very, very quickly and implement them without the bureaucracy that's found at NASA. So if anybody can do it, I think it's Musk. But I think that, as we said in the first segment, there are some real issues in terms of keeping the passengers healthy, which will take some very important basic research that really can't be rushed.
Okay. Now, Amanda, let's talk about the science of being on Mars. First of all, the air. Tell us a little bit about the carbon dioxide atmosphere and how cold it is. It is, of course, a frozen planet, the planet Mars. And what it would be like for an astronaut to build the first manned space station, a base on Mars. Tell us a bit about what it's like to live on Mars.
Well, Mars is an interesting planet. It would be, to live on Mars, I would think would be maybe okay for kind of a while. It's cold there. There's not much atmosphere at all, and it's certainly not a breathable atmosphere. And it's not a very thick atmosphere. So astronauts, colonists would have to wear pressure suits. They would have to bring their own oxygen, of course, to breathe. And they would need habitat that would keep them safe from micrometeoroid bombardment and from radiation, and would give them kind of a stable temperature because there are wide temperature swings between day and night. But some more positive aspects of Mars are that there is water there, of course. At the pole, there are polar caps that have water, frozen water in them, and there's water in the subsurface, frozen, even down to lower latitudes. So that makes things a little easy in terms of providing water for astronauts and colonists to use for fuel and for building and for drinking.
Okay, well, let's take another short commercial break, and we're going to continue a discussion of what would it take to begin the colonization of Mars. With us today is Charles Walford. He's authored 10 books, hosts a weekly interview program for Alaska Public Radio, and is a winner of the Los Angeles Times Book Prize for Science and Technology. Dr. Amanda Hendricks is a planetary scientist, worked for 12 years for NASA's Propulsion Laboratory, and has appeared on numerous TV programs and is the principal author of many scientific papers. And the book is called Beyond Earth, Our Path to a New Home in the Planets. And once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call and be part of the fun. Well, let's take a short commercial break. And after the break, we're going to talk about building a city on Mars and then beyond Mars, perhaps to Saturn and one of its moons, Titan. So stay tuned as we blast off into outer space.
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Today we're going to blast off. We're going to go past the moon. We're going to go on to Mars and even beyond Mars. With us today are the authors of a new book called Beyond Earth, Our Path to a New Home in the Planets. Charles Walford and Amanda Hendricks. Charles has authored 10 books, hosts a weekly interview program for Alaska Public Radio, and Dr. Amanda Hendricks is a planetary scientist and worked for 12 years at NASA's Propulsion Laboratory. Charles, you probably saw the movie The Martian, and there's Matt Damon struggling to maintain a little bit of oxygen and enough food to keep him alive for a few weeks. What are your thoughts about the movie? Was it realistic, and did it really portray the difficulty of living on this rather hostile environment called Mars?
Well, obviously different people had different opinions about it. We spoke to some scientists at NASA who thought that there were some issues in the movie that weren't that realistic, especially the way the food production was done, that he probably would not, what he did probably wouldn't have worked in terms of growing the potatoes. The other issue that I don't think is really addressed is the radiation, as we discussed earlier. The shielding that's needed for a long stay on Mars is pretty considerable. You probably want to have your habitat underground in order to really survive that radiation long term. So, I think there were, I really enjoyed the movie, and I think sounds like it was a great book with a lot of engineering in it, but I'm not sure that Matt Damon would have made it.
Okay, so Amanda, what are your thoughts? Was it realistic? I mean, if it really happened like that, do you think he would have survived or would have perished for lack of oxygen, lack of food, lack of all sorts of things?
Well, I think he was quite innovative and clever in the techniques that he came up with to get himself out of jams here and there, and it was certainly entertaining. I think overall it was not too far off. The main issue that I had scientifically with it was about the atmosphere and the windstorm that came up. We know that there's dust storms on Mars every so often, but there's just not enough atmosphere to create that much wind, as was portrayed in the film. But it made it more exciting for the movie, that's for sure.
Right.
And of course, I don't think that they were planning on staying there for very long. So I imagine that after coming back to Earth, Matt Damon's character would have suffered from tissue damage and possibly a shortened lifespan due to his accumulated radiation over his longer than planned time on Mars. But certainly any longer-term colonization of Mars would need to plan for some sort of underground habitat to help shield from that radiation.
Well, let's take another short commercial break.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today are two authors of a new book called Beyond Earth, Our Path to a New Home in the Planets by Charles Walford and Amanda Hendricks. And before we were talking about the colonization of Mars. However, they're more ambitious. They see Mars as a stepping stone to Saturn as we go to Titan, one of the moons of Saturn. So, Charles, why did you say Titan when most science fiction writers and Elon Musk, the billionaire, are concentrating on Mars?
Well, I think that the concentration on Mars is because it's the nearest planet, and seems like the easiest to get to. But we started our project in Beyond Earth in looking at where would be the planet that would be easiest to live on, where you could survive with the fewest technological interventions, and that was Titan. It's a moon of Saturn, which has a thick nitrogen atmosphere and has a very plentiful supply of hydrocarbons and water that would allow you to have pretty much unlimited energy supplies. So it gets you through many of the environmental problems you would face on Mars and allows you to think about a society living there permanently, self-sufficiently, without connection to the Earth.
Okay, well, Amanda, Titan has a lot of, I think, what is called ethane, and it is potentially combustible, but it requires oxygen. Therefore, you cannot light a match on Titan in order to burn some of the hydrocarbons there. So is it really possible to harness the fuel on Titan, given the fact there's no oxygen to oxidize the fuel?
Yes, it is. And again, it's not a super straightforward problem, but there is water on Titan. As a matter of fact, it's made up, a bulk of it is made up of water ice. And so in Beyond Earth, we envision a scenario where settlers on Titan could set up basically a factory where they dig up from the subsurface, and it's probably not that far into the surface, water ice, and convert that through electrolysis to oxygen and use that to burn the methane and other hydrocarbons that are so plentiful there. Another thing that I wanted to say about the desirability of Titan over Mars or other planets in the solar system for a human colony is just its Earth-like qualities. You know, we thought a lot about where would be a good place to set up a human colony in the solar system. And there's a lot of reasons to rule places out because they're too hot, too cold, not enough atmosphere, not enough gravity, and so forth. But there's also the aspect of how Earth-like a planet is. And Titan, surprisingly enough, is probably the most Earth-like planet or planetary body in the solar system. There's lakes on the surface. It's the only place in the solar system where there's liquid on the surface other than on Earth. Of course, it's not water, it's methane and ethane, but it lends an Earth-like quality to the surface. Again, there's the atmosphere that, as Charles mentioned, is mostly nitrogen, so we can't breathe it, but it is about 1.5 times the pressure on the surface as Earth's atmosphere. And so that gives you a lot of opportunities for movement through the atmosphere. You could fly if you wanted to, strap on some wings and fly. You could sail a boat across the lake. There's dunes there made up of hydrocarbons. So a lot of potentially pleasant aspects to living on Titan in terms of transportation and lifestyle. Even though it is cold and far from Earth, if you can overcome a few hurdles, there's a lot of good aspects to living on Titan.
Well, Charles, our early pioneers lived off the land by, of course, growing crops. Some people think that one day we'll grow crops on Mars because it has a carbon dioxide atmosphere, and perhaps we'll genetically engineer algae and stuff like that to live on Mars. However, Titan has no soil as we know it, no organic soil, plus it's very cold. There's no carbon dioxide for the plants to breathe, and so agriculture would be impossible on Titan, right? What are your thoughts?
No, I don't think it would be impossible. The agriculture would obviously have to be very different than it is here on Earth, partly whether on Mars or on Titan, because it would have to be done indoors. Both places are very much too cold for any kind of organic life that we know of. So you would have to create, you can think of it as greenhouses, but in fact, to have the productivity that you would need, you'd have to have some kind of algae generator or other high-tech bioengineered food system to provide enough sustenance, enough calories for a large society. But, the amount of time and technology advancement to get us out there, if that development is going on at the same time, it probably can be done. In terms of the gases that you would need, you've got everything there you need, and you can certainly create whatever atmospheric constituents you need from what's found on Titan in the abundant water and hydrocarbons. So I don't think that that's overcomable, something that you can't overcome. But the advantages are so great of having protection from radiation and of having this energy source and of having the other resources you need to become self-sufficient that we think that, and we try to make the case in Beyond Earth, that if you want to consider a colony like, say, America, where people go and they don't need to be supported by the old country, in America, I guess it would be Europe, then you need to look to a place that has those resources and that ability for self-sufficiency.
Okay. Well, unfortunately, we have run out of time. But Charles, Amanda, thank you so much for being on Science Fantastic.
Thank you.
Thank
Enjoyed
you.
it.
And once again, the book is called Beyond Earth, Our Path to a New Home in the Planets by Charles Walford and Amanda Hendricks.